Right, go ahead and copy down this top part for me. 2-4, solving equations with variables on both sides. And these two parts right here, okay? For this week, you're gonna have 2 sections, 2 worksheets, quiz, and notes to upload, okay? It's kind of the same deal, similar deal to last week. Except we did a little bit more notes than we did last week than we did this week. And go ahead and write these 2 little things down right here for me while you're writing. Simplify both sides and get variables on the same side. Alright, we kind of solved these just like the multi-step equations that we were solving last week. The only difference is there's variables on both sides. So last week we just had like an x on like this side of the equal sign. Now there's an x on both sides. Okay. So the first thing you got to do is we're going to simplify both sides of the equal sign. Okay. If there's anything that we can do, if there's any distributed property, combining like terms, anything like that, we have to do that first. That's on the same side. Then we have to move one variable to the other side of the equal sign. Okay. And then we solve it just like all the ones we were doing last week. We use PEMDAS backwards. Nothing else changes. Okay. Getting closer, Chandler.
Yeah.
All right. Let's go ahead and write this first problem down for me. 5x plus 2. 5x plus 2 equals 2x plus 14. Okay, 5x plus 2, 2x plus 14. First thing, simplify on both sides. Is there anything I can simplify on either side? Any like terms put together, any distributed property? No, I don't see any of that either, okay? So I'm gonna start off by moving a variable from one side to the other, and I'm gonna do that using inverse operation, so the opposite. I can do either one. I can move this 5 to this side, or I can move the 2 to that side. And I think I want to try to do it where I have less negatives. That's kind of my goal here. So if I move,
Pardon the interruption. At this time, sophomores J through P go to the gym, home side balcony. Please stay masked and keep your distance. Thank you.
it'd be last thing. Or you'd be probably the next group. All right, so I'm going to start off by moving this 2 to the other side. So I'm going to subtract 2x from here. If I do it on this side of the equal sign, I've got to do it on this side as well. So this cancels, and that leaves me 3x plus 2 equals 14. Now it's just like one of those multi-step or 2-step equations that we solved last week. I got to get the x by itself. On this side of the equal sign, it's got a plus 2 and a times 3. So a plus 2 and a times 3. If I do PEMDAS backwards, start from the bottom and go up, that means I should move that 2 to the other side first. So I'm going to subtract 2 from here, subtract 2 from here. So that's gone. That leaves me 3x equals 12. Last step is to divide by 3, divide by 3, and x will equal 4. I'm good with that? Good with that? Let's come on down here. Let's look at this one. Solving an equation with grouping symbols. Go ahead and write that one down for me. Just the problem. You don't have to write anything else down but the problem.
So anything you write on the board, we don't have to write down.
Anything I write on the board. Yeah, what I write on the board, you got to write down.
Oh.
So you don't have to write all of it. You just write the problem. Just that part. Okay.
Okay.
And then you write whatever I write down too when I start to solve it.
I was confused.
Okay. Yeah,
I'm sorry, Minnie.
You're fine. Yeah, I'm just meaning you don't have to write like solving an equation with grouping symbols. You have to write that part.
Okay.
All right, so here I've got some simplification. Looks like I can do here. I can start off by doing distributed property, I think, on both sides because I have numbers sitting outside of parentheses, right? So I could distribute this 2 to everything on the inside, and then I could distribute this 3 to everything on the inside. So by distribute, I mean to multiply by those things, right? So once I do that, 2 times 5x will be 10x minus 2 equals, and then I'm going to do the same thing over here. So 3 times x is 3x. 3 times 11 is 33. All right, now it's very similar to the one I did a while ago. I'm going to start moving some variables around to the right side. I've got a 3x over here. I'm going to subtract it so I don't have any negatives. So I'm going to minus 3x minus 3x. So that's gone. That leaves me 7x. Sorry, make it a little cleaner. 7x minus 2 equals 33. All right, from here it's a two-step equation, just like what we were doing last week. So I'm going to add 2, that's gone, gives me 7x equals 35, divide by 7, and x will equal 5. You good with that? Yep,
I'm not done yet.
that's fine, you got time. Don't worry about it.
I'm done.
Right. Any questions so far? Just on those two problems? It's not too bad. It's something you've done before. It shouldn't be anything new. All right, go ahead and write this one down. 10x plus 12 equals 2 times quantity 5x plus 6. All right, what will be our first step here, Emily?
Distribute.
Yeah. Yep. First thing I'm going to do is distribute this 2 to both things that are on the inside. Okay? Distribute to both things that are on the inside. When I do that, I'm going to write everything else down. I'm going to bring everything down. 10x plus 12 equals, hey, 2 times 5x is 10x. 2 times 6 is 12. Huh. It looks weird, doesn't it? Why does it look weird? It's the same on both sides. Okay, let's keep going. Let's just keep that in the back of our minds, okay? Keep that in the back of our mind. So the first thing I'm going to do is move one of my x's to the other side, right? So it don't really matter because it's the same thing on both sides. So if I do minus 10x over here, cancel that out, and minus 10x over here, and cancel that out, hey, I'm left with 12 equals 12. Any ideas? Any ideas? It's kind of a trick question. Huh? It's not 0. So check it out. Anytime you're doing an equal sign and you end up, or an equation, and you end up with the exact same thing on both sides, it's a really easy problem. There are this many solutions. What's that sign mean? Infinitely many solutions, okay? So pretty much any number that I want, I can take and plug into x and it will give me a true statement, okay? So this is infinitely many solutions. Or you could also say all real numbers. Some people say that too, okay? Infinitely many solutions or all real numbers. Okay, so just pick your favorite number, Chandler.
20.
20. If I plug a 20 in here and I plug a 20 in here, I'll get the same thing, right? It'll work. It doesn't matter what I plug in, I'll get the same thing. Good with that? All right, now let's look at this one. So actually, whenever I got to this step right here, I probably could have stopped. I wouldn't even have had to do that last step because it equals the same thing on both sides. I could just say, okay, that's infinitely many solutions. Go ahead and write this next one down for me, please. This one might be a little different. All right, what would be my first step here?
Add the like term.
Yeah, add like terms that are on the same side. So I've got a negative 3m and a positive 12. Negative 3 plus 12 gives me 9m. And then I just bring my 5 down, equals 9m minus 4. All right, it's kind of going to be like the last one, but let's see. But it's not the same thing on both sides, is it? It's definitely not the same thing, because this one has a 4 and that one has a 5. So it's not going to be the same. It's not going to be infinitely many solutions. All right, let's go ahead and start off by moving a variable to the other side like we have on all the other ones. So I'm minus 9m from here, minus 9m from there. there. That's gone. And that's gone. That leaves me negative 4 equals 5. Does negative 4 equal 5? No, that doesn't make any sense, does it? Negative 4 equals 5. That makes no sense. So guess what this means? In the last one, there were infinite many solutions. So in this one, there's going to be no solution. If you ever cancel out your variables and you get two things on like on each side of the equal sign that are not actually equal, that don't make sense, then it's going to be a no solution problem. Okay, cool with that? Cool with that? Everybody good on that one? All right, one more section to do. We're going to skip a couple in the middle. Go ahead and write this, 2-7, solving proportions, and that underlined sentence right there for me. It's the last section.
Pardon the interruption. We need the rest of the sophomores to go to the gym, home side balcony. Please stay masked and keep your distance.
No, you'll be back. You got 40 minutes left in class. All right, got that written? Out of everything I teach you, out of everything you learn as a freshman, solving proportions might be the most useful thing that you'll ever learn. Like, I use these all the time, okay? I can't honestly say that I like graph quadratics every day of my life, you know, and it helps me, but solving proportions is definitely something that can help you, okay? A proportion is an equation that states that two ratios are equal. Y'all have heard of proportions, correct? Y'all have heard of that? So if I have a proportion, it's just something, it's saying two things are equal with an equal sign in the middle, two fractions, okay? That's usually how proportion works. If they look like this, they're just simple proportions to solve. All right, there's two ways we can do it. I think maybe you all were taught maybe the butterfly method. You ever heard of that? Anybody ever heard of that? You use cross products, okay? Because one of the rules of a proportion is that if I have a proportion, let me make this a little bigger so you can see it. I'm gonna rewrite it. 7 over 8 equals m over 12. So one of the rules for a proportion is the cross products have to be the same, okay? That means if I take 7 times 5, or 7 times 12 here, multiply those together, and then I take 8 times m, multiply those together, they have to be equal, okay? That's a rule of something to be a proportion. So that's what I'm gonna start off doing. I'm gonna say 7 times 12 equals 8 times m. Hey, that just looks like a one-step equation, doesn't it? Kind of like the ones that we've done before. So let's figure out what that is. Let's see what 7 times 12 is. Let's simplify that part first. 12 times 7 is 84. This is 84 equals 8 m. 84. How would you solve this one? How would you solve it?
84 times 8?
Divided by it. Right, because it's already being multiplied on this side. It's already being multiplied, so I have to do the opposite. I divide by 8, divide by 8. And 10.5 equals. Remember how to do that? Also, another kind of shortcut that I see people use is cross multiply and divide. So take the two numbers that are right across from each other. I think this is kind of easier. This is what I do. The two numbers that are right across from each other, the two actual numbers, okay? So 7 and 12. Multiply those two together and divide by the other number. That's basically what I did. That's the same thing I did over here, but you don't have to write out all that work if you do it that way. okay? Because if you take your calculator and say 7 times 12
84.
divided by 8, 10.5. Cross multiply and divide. So let's do that in here. Let's do that way here. You can't always do that, but for some of these simple ones, you can do that, okay? So I have 4 thirds equals 8x. Which two numbers are right across from each other? Which two actual numbers are like diagonal? 3 and 8, okay? So if I take 3 times 8 and divide it by 4, I should get the right answer. So 3 times 8 is what, 24? 24 divided by 4 is 6. And you can do all that on a calculator. Is that easy? Is that easy enough? Alright, so like I said, that little shortcut works really well for ones that look like this. It doesn't work so well for ones that look like this though. We have to come back and do the same thing we just did a while ago and solve our proportions, okay? Do our cross products. We got 2 more examples for you, okay? Almost done. So we're going to use our cross products here, just like we did a while ago. So I'm going to take this one, multiply it by that, and this one, and multiply it by that instead of equal each other. So I have b minus 8 times 4, the whole thing. And I also have 5 times b plus 3. And they got to be equal to each other because they're cross products, okay? The rules of cross products say they have to be equal. So here, I'm going to just start off solving an equation just like I would a while ago, okay? It looks just like those multi-step equations I was doing earlier. I'm going to do distributive property on both sides. So I'm going to take the 4, multiply it by everything on the inside over here, and I'm going to take the 5 and multiply it by everything on the inside of those set of parentheses over there. 4 times b is 4b. 4 times negative 8 is negative 32. 5 times b is 5b, and 5 times 3 is 50. Pretty easy equation from here on out. I'm going to get my variables on the same side. I think I'm going to subtract 4 from both sides so I don't have any negatives. Okay, if I want to, I could subtract the 5. I'll get the same thing. So I'm going to subtract 4b from here minus 4b from there. So that's gone. That leaves me negative 32 equals 1b plus 15. Now it's a one-step equation. I can subtract 15 from both sides. Minus 15. Was that negative 47? Negative 47 equals 1b. Now at this point, do I have to divide by 1? No, I don't have to do that. I can just say b equals negative 47. Because if you divide by 1, you won't get anything from it. You'll get the exact same thing. Okay? Negative 47 equals b. Alright, last problem. Good, Chandler? I'll put it back up if you need me to.
Okay, I'm done.
Alright, you do have a couple of word problems on your homework for this week. Okay, proportions word problems. Everybody loves them. They're everybody's favorite kind of problems. They're pretty easy though. I got a good method for solving proportions word problems. This one says a portable media player has 2 gigs of storage and can hold about 500 songs. A similar but larger media player has 80 gigs of storage, but how many songs can the larger media player hold? Okay. This is kind of funny because this is an older textbook, obviously, but you all don't have, most of y'all don't have like just MP3 players anymore like we did back in the day. But I remember everyone else had like a 2 or 3 gig little like MP3 player, but Coach Gray back in the day had like a 40 gig one, and it looked like a Pop-Tart, and it held like 600 songs, and everybody thought it was the most awesome thing ever. So you can ever ask Coach Gray about his Pop-Tart. It was actually on iPod, I think is what it was. So he was cool. He was way cooler than all of us. And we all had illegally downloaded music off LimeWire, and all of our computers had viruses from having to illegally download all the music off there. So it was a good time. Good times back in the early 2000s. glad y'all didn't have to look through all that. Alright, so right here, when you're doing a proportions word problem, okay, find the two quantities, like find the two things that are like the two parts of the problem. So I have two things in here. It looks like I have gigabytes, which are gigs, like you've heard of on your phone, okay? I have gigs and I have songs, okay? So that's how I'm gonna start. I'm gonna write the two things that I have down. I'm gonna write gigs and I'm gonna write songs. Just like this, okay? I'm gonna put them over a fraction. Just like that, okay? Now, beside it, I'm gonna make a proportion, just like this. Two division symbols and a equal sign in the middle. All right, as long as I line everything up here, I can't mess up. Okay, so on the top is gigs, so I'm gonna put gigs and gigs. What are my two numbers that I have for gigabytes?
2 and
I have 2 and 80, right? Those are my two numbers for gigabytes. Now the only thing that you can mess up here is by not putting the right ones together, okay? So now I've got songs, I've only got one of them, right? I've got 500 songs. Does it go with the 2 or does it go with the 80 in the problem? It goes with the 2, right? So I'm gonna put it right here, underneath there, and I'm looking for that one, so it's gonna be an X. Everybody see how I set that up? This is important. If you bring your homework to me and you don't know how to do it, I'm gonna make you write this down, just like I did it, okay? And keep everything in line. Now we're gonna solve it just like we did that last one. I'm gonna do cross products. I'm gonna multiply these two together and divide by that one. 80 times 500 is what, 40,000? Big number, right? I think so. So 80, let me double check. 80 times 500 is 40,000. And then 40,000 divided by 2 would equal 20,000 songs. So X equals 20,000 on that. All right, questions? Anything? That's pretty good. 25 minutes.